We were on number 12. You buy your first car for $6,500. That's your principal. One, and the car is going to depreciate. Therefore, it's decreasing. It also says the word decrease at a rate of 2.6%. If I divide it by 100 and change it to a decimal, it's 0.026, and it says for 4 years. So on this one, we want to match this this equation here up with the choice. And if you look here, inside the parentheses, you can simplify that, and that's what happened to get to the answer. If you do 1 take away 0.062, you get 0.974, and it's still to the 4th power. So that is going to be answer B. That's the one that would give us the same result as this that we wrote out. Make a table, graph, and equation from the situation below. A tree frog population triples each month. Suppose that currently there are 10 tree frogs in your backyard. So your tree can hold at most 21,870 tree frogs. So if we're going to make a table, remember time is always x. So I could put x here, or I could put an m for months. Might be more helpful. And the output is how many tree frogs we have. We could say y, or we could put f for frogs. So in this case it says we have 10 to start out with. That means at 0 months we have 10 frogs. And each month the frogs triple. So after 1 month the number 10 triples, or that's timesing by 3. So we're going to have 30. Then the next month the 30 triples. So 30, 30, 30, or times it by 3, we get 90. And we would keep going and do the same thing. 90, 90, 90, or 90 times 3 is 270. And if we want to graph that, we're going to have months here and our number of tree frogs on the y-axis. So this is months. All we need to do is go out to 3, because I did only to 3 here. So 1, 2, 3. And if we need to get to 270, maybe on the graph we go by 60s. That's what I did, but you don't have to go by 60s. That's just an example. So 120, 180, that'd be 240, and up here we'd be at 300. So we got 0, 10, which would be way down here. 130, so that's about halfway, because if we go by 60s, it's halfway. And then 290, 90's halfway in between here. And then we're going to be at 3 and 270, so that is way up here. And that is our tree frog population. Then it says that we need an equation. There's more than one way you can write out your equation. If we do subscript notation, we'd have a sub n equals the number that we're starting out with. If I use this first one here, we're starting out with 10. Right? If we're given month 0, that's the one we want to use. It's repeatedly timesing by 3 each month, tripling, and it's to the nth power. And there's no minus anything because this is at month 0. So this is one way we could write that. We could write it as y equals 10 times 3 to the x. Again, it's the same thing, just looks a little different. We could also put fx in function notation and put 10 times 3 to the x. So those are all good ways of writing out the equation. How many months does it take for your tree to be completely filled? Well, you could just keep going in your table. It says here's when we fill up the tree is the 21,870 frogs. And if you keep going with the table, or you could plug numbers into your equation. You could plug in a 4, a 5, a 6, a 7, 8, and figure out when are you going to get either this number or a little bit more, because if you're getting a little bit more, it's going to be completely filled. So to do that, it's going to take 7 months. Again, you could have just kept going in your table and seeing when that happened. Number 14, circle the words that describe the table and explain why you circled them. So we're going to find out what our table is doing on the rise and the run. So if I go from 2 to 4, that went up 2. From 4 to 12, that's up 8. And 12 to 18 is up 6. Over on this side, for 2 to 1, it's down 1. 1 to negative 3 is down 4. And then negative 3 to negative 6 is down 3. You could check the table to see if it's multiplying or dividing. It would be pretty difficult to look at those numbers and decide that. But first, the easiest thing to do is check linear or exponential. So if we take our rise and run numbers and see if they're consistent, if we simplify those. So if we have negative 1 over 2, well, that's our top one, right? These two. That doesn't simplify, and that's what we have. If we have negative 4 over 8, that does simplify, and that is negative 1 over 2. If I have the last one, you got negative 3 over 6. Again, that does simplify to negative 1 over 2. And if you notice, our rate of change or slope stays consistent. It's constant. So a constant rate of change makes a linear function. And if you notice, each of the numbers or our slope, our constant rate of change, was negative. Therefore, we can circle decreasing. And also, when we're linear, we're going by the same amount every time. And therefore, that is arithmetic. Number 15, an exponential function. Oh, and explain why we circled them on the last one. Well, I believe that all the work we did there does explain that. Exponential function fx equals a times b to the x, where a, b are constant values for the function. And we've got our table here. So already we know this is exponential because it tells us in the problem. That means that we are either multiplying or dividing on this. And so to figure that out, these numbers are a little bit hard to figure that out, right? If I go from 36 to 24, I'm not quite sure what that's multiplying by. So what you can do is you can take the second number, the bottom, and divide it by the top. Just like we would over here, we could do bottom minus the top. Here I can do bottom number divided by the top. So if I do 24 divide 36, I get the decimal of 0.6 repeating, which if you change it to a fraction is 2/3. So here we know it's multiplying everything by 2/3. And if we want to write what is the equation for the table, we're going to have fx equals, and it's a times b to the x. There's no -1, so we have to use the 0, the y-intercept right here, which is 81 times the 0 term. So 81 times, we're repeatedly multiplying by 2/3 to the x. That would be our equation. And if I go to graph that, I'm going to have, let's see, on the graph I can go by ones here, but on the y-axis, let's see, we need to get to 121. So you could go by 10s. I decided to go by 20s. 20, 40, 60, 80, 100, 120, and, well, 140. If I graph -1, oops, I wrote my numbers on top of there. But if I go to -1, I'm going to put it on top of here anyway. -1 is here. I go up to 121, which would be right there. 0 and 81. 1 and 54. 2 and 36. And then 3 and 24. And we could keep multiplying by 2/3 and finish that out. But here is our exponential function graphed. All right, there are 3 functions given. Determine whether each function represents linear, exponential, quadratic, or cubic. Well, because we haven't talked about quadratic or cubic, they're probably going to be linear or exponential. So if I look here, notice that the x column goes by ones and the y column is what we need to figure out. If I go from 7 to 21, I could multiply by 3. If I multiply 21 by 3, I don't get 35. So the other way to go, I could add 14. And if you keep adding 14, that would then be linear. And it works, right? If you keep adding 14, you can see that that works. Over here on this one, 7 to 21 again. So I could multiply by 3,